audit for a standard and get a audit certification like ISO 27001 certified or SOC 2 certified, right? Against a particular standard. You can be COVID certified, you can be ITIL certified, you can have quality certification. So you have to carry out periodic audits to maintain the certification. Generally carried out once every 3 years. Okay. And then the most important part of security testing is the vulnerability assessment. Now, what is vulnerability assessment? Vulnerability assessment is done to find out vulnerabilities in your organizational entire information security aspects, right? Now, vulnerability assessments will require tools if they are network based. It might also require, physical checks to see are there any vulnerabilities in your physical environment. Okay, if it is a technical environment, you might use tools, right? So what happens is in vulnerability testing, if there's physical controls, you carry out physical tests. If it is on the network, on IT assets, then you carry out with vulnerability assessment tools. What are the most common vulnerability assessment tools generally used in enterprises? One is Nessus and second is Qualys, right? Tenable. Now it is called Tenable, right? These are the two most common, enterprise grade vulnerability assessment tools. There are many other tools such as OpenVAS. Okay. Excuse me. OpenVAS is a open source tool which can be used for vulnerability assessment, right? Now, you might run a tool, but you need to know how to describe vulnerabilities. Okay. Now, what happened initially once, there were a lot of vulnerabilities and software vulnerabilities, hardware vulnerabilities, physical vulnerabilities. You needed a common platform to define vulnerabilities or a common language to define vulnerabilities so that everyone was at a same level. Then NIST came up with I will say, a protocol called the SCAP, Security Content Automation Protocol. Now, that is now the world over the most agreed upon protocol for describing vulnerabilities, how to describe vulnerabilities. The first part of the SCAP is the CVE. We all have heard of it, right? Common vulnerabilities and exposures, CVE. Now, CVE is the moment you look at a CVE, you know, okay, this is the vulnerability, which is the operating system, which is the system, which is the software, and what is its risk score. Okay, it gives you a scoring, right? So that the description, how you want to describe a vulnerability in a software which you have made, you can just go to NIST's website and find out what is the CVE, how to describe a vulnerability. Okay, so everybody can have a common understanding of how to describe vulnerabilities. Now, once the vulnerability has been described, then you need to tell how important or how critical it is. That is given by CVSS, Common Vulnerability Scoring System, CVSS. CVSS gives you a score 9, 8, 7. It is from 1 to 10. I think 1 to 9, if I'm not wrong. 9 is the most critical and 1 is the least critical. Okay. But most of the times, it's not necessary that having a 9 vulnerability in your system actually makes you vulnerable. Okay. Because at times you might have systems which are internal to your network and not exposed to the internet. So you might see that, that vulnerability though might be very critical, but you wouldn't like to patch it at that point in time because it's internal or on a segmented or a segregated network. And it may not effectively be actually working against you. So what happens is you need to carry out a assessment in your end. Just because it is critical doesn't mean it is critical to you. You have to see whether it is critical to you. And that's why to do that, you need a proper risk management process to see whether a vulnerability actually poses a threat or not. Because at times what happens is if there is a vulnerability and you have a patch, you patch a system and your production systems go down because your softwares may not be designed for the patch. Okay, and your systems go down. Okay, once you have done CVE and CVSS, then you come to configuration management. So if there are any configuration issues, how to enumerate configuration is given in a protocol called Common Configuration Enumeration, CCE. Okay, and then if you have platforms which are, you have a system platforms in which vulnerabilities are there, platform-based vulnerabilities are described using common platform enumeration called CPE. Okay. Now, once you do all this, you might need to exchange this data between two different systems. Okay. Say NIST has a database in which it has put CVE, CVSS, CPE, and CCE. And now you want to pull that data into your environment and do a risk assessment, risk matching. Okay. So there are two languages which understands how to format this data. Okay. One is XCCDF. It's an extensible configuration checklist description format, wherein it's a language in which everybody describes the configuration checklist. And the most common language for exchanging vulnerability data is OVAL, Open Vulnerability Assessment Language. Now, if you're developing a product which wants to incorporate vulnerability assessment data, you can use OVAL to incorporate the data from multiple vulnerability assessment sources into a software which you are developing on your own. Okay, so that is about how you should describe vulnerabilities. Now, for finding vulnerabilities in network systems, you do multiple kinds of scans. Okay, you can do network scans using Nmap, right? Then you can do web vulnerability scanning using Burpsuit. Okay, then you have SQL search. There are many tools. There are thousands of tools you can use to carry out vulnerability scanning for whatever kind of resources there in your organization. Okay. Now, one of the most common way in which both hackers and red teamers carry out a network scan to find what all assets are there on the network, okay, is by something called network discovery scanning. Now, network discovery scanning can be done by a tool, Nmap, or manually from command line. You can do a command line search also from system. Okay, Nmap is the most common tool which is used for network discovery scanning. Okay, Wireshark is used for also doing network discovery scanning. And Wireshark can tell you because it reads a lot of IP data set, right? So it can actually tell you what all systems are running on your network. Okay, then you can actually, now in Nmap, you can actually change what kind of scanning do you want to do. So if you want to do only a TCP scanning, so you can do TCP SYN scanning. So if you do a TCP SYN scanning, what Nmap will do, it will send a SYN packet to each and every IP which it detects on the network. Now, the moment you do that, you will get a SYNAC packet. The moment you get a SYNAC packet, you come to know which all systems are live. So what is the main importance of SYN scanning? Basically to see what all systems are live. Then you can do a TCP connect scanning. You can say, okay, let's open a connection with the host. And you send a TCP connect scanning packet. And that basically establishes a connection with the client on the network. Okay. You can also do ACK scanning to see whether some systems are trying to close the connection, or some systems are sent a SYN packet and waiting for a acknowledgement. So there are many ways in which internal red teamers and hackers try this. So if you ever read a firewall log, you will see such kind of scannings continuously being done on your network. So today's question, Nmap, gives what kind of reports. So when you do carry out Nmap scan, you can do a scan on your own laptop. Once you do a Nmap, okay, sv.sv, okay, basically you are trying to find, this is the command, you run this command, okay, and you will find what all ports are there and whether they are open, whether they are closed, and whether they are filtered. Okay, so filtered means there is a firewall on that system and that port is behind a firewall. It might be open, it might be closed, and Nmap doesn't know, but it knows that it has been filtered. Okay, so right, so this is what Nmap does and lets you know whether a firewall is there or not. Right. So you have a lot of tools which you should generally be aware of. One or question, at times it comes. If you have gone through Cybex, you will be able to easily find out whether these are generally one or short questions which sometimes come. Okay, but never are the core part of your exam. Okay. Once you have passed the exams, one or question like this, is thrown to just complete the exam. Right. Now, vulnerability scanning. If you do a broad scan, you will get a lot of false reports. You will see a lot of data, and that's why you have to do very, very accurate scans, authenticated scans to find more. I'll say a data which is more specific. Okay. Tenable is there, Earcrack is there. There are a lot of tools available which can do network vulnerability scanning for you. Web vulnerability scanning, I told you, you can use tools like Burp Suite. Okay. You do web vulnerability scanning to find out vulnerabilities in your web application. Now, vulnerabilities in web application are generally given out by OWASP. Go to OWASP top 10 websites. It tells you about the 10 most common vulnerabilities on web applications in last 1 year. Okay. Security professionals use this as a reference benchmark to tell the developers that, always carry out, these as the most common vulnerabilities on your web-based product, and utilize, the remediations given so that you do not have those vulnerabilities on your website. Okay. Now, web applications, the most common, vulnerabilities on web application, which you are worried about, is the SQL injection. Now, SQL injection, what it does is, generally, most of the websites which are running, will have a database, which is SQL based. Okay. And they will have a application logic, right, which is running either on JavaScript or Python or PHP, okay, whatever. And then they have a web interface, okay, they have a web server, right? And then when they open the web server, you have certain data points which you take from the user. Some inputs you take from the user. When you take these inputs, the web server sends it to the application. The application server tries to query the SQL to take that database. Now, at times, if you have not carried out input validation here, again, if you look at SQL's architecture, SQL was not built for security. It was built for simplicity. So what happens is, if you input a small SQL command here, and your application is not checking this input, then it will execute the SQL query, and actually you will throw out the complete data outside. This was a very common vulnerability, and it still exists. Developers are still not aware. They do not do input validation at the application level. So you are supposed to do input validation. What is the input from the user? Okay. Try out on any of the banking application $sign. It will never accept the $sign, because the moment you say dollar and type select, you type a command select $. Okay, it will simply reject you. Okay, it would take you as a attacker. Okay. So this is one of the most common vulnerabilities, and the common vulnerabilities are given out in OWASP, and developers should be aware of these vulnerabilities and the remediations, which are very, very simple to be incorporated in the web application code. Okay. Similarly, for databases, you might have databases have a habit of, getting injected. So you have a database. Okay, if you have not properly taken input from the application, then what happens? Hackers can inject data in the application, which will go inside your database. And that's why you need to do a database vulnerability scanning before hosting it on production. Okay. There are multiple tools. SQL Map is one of the tools to find vulnerabilities in your database. And then how do you manage the vulnerability workflow? Your main aim is to detect a vulnerability, validate that vulnerability is actually effective in your enterprise, and then remediate the vulnerability. That is, meet the vulnerability and close the vulnerability. Okay. Right. So let's take a break. Time now is 7:14. Let's be back at 7:25. Okay, 11 minutes break. Any questions, please ask. We're generally easy topics, right? Most of us know these topics. Yeah, because rest 3 are generally controls, right? They are not part of your vulnerability management. You carry out vulnerability scans to find any vulnerabilities on such systems, right? Okay, next part. Once you've done vulnerability assessment, what you do is penetration testing. Now, penetration testing is considered an offensive action, okay, as per the security, I'll say, sales industry, okay. Whereas, in any organization, we have been carrying out such testing over a period of time. There is nothing called penetration testing. It is not an offensive security action. Okay, it's basically a terminology for sales guys to, sound it more, saleable, right? So it's considered as offensive security, which basically emulates how a hacker would hack into your, or a attacker will, gain access to your system. Now, whenever you're doing penetration testing, it involves planning. That is, you plan how would you like to target a system. Then you carry information. There's an information gathering and discovery phase, wherein you try to find out IP addresses, kind of firewalls laid out, what are the internal systems. Okay. Once you found out that, then you attack the system. You actually deliver a payload, okay, and see that whether your systems are vulnerable to external attack. And then finally, you do a reporting and tell it to your client that, or tell your internal systems that these are the vulnerabilities in your system. And this is how we have been able to penetrate into your system, right? Pen test types, 3 types: white box, gray box, black box. White box is, you know everything about the internal system. If you know about everything about the internal system, the task of the penetration testing teams becomes easier, right? They do not have to search everything from start. Now, that's a good approach. But at the same time, if you are incorporating external pen testers, then it carries certain amount of risk, because it has been seen at times that penetration testers in daytime becomes active hackers in the night time. So would you like to expose your internal systems to penetration testers? That's why most organizations do not go for a white box approach. But at the same time, if you go for a white box approach, the work becomes easier for the penetration testing team. So if it is a very, very reputed agency, you might go in for a white box testing. Or if you have your internal testing teams, that's why bigger organizations, large organizations have their own internal penetration testing teams. Okay. Then you can go for a black box testing. Black box testing is, you don't tell anything about the system. It's like the real situation. Okay. So the penetration testing team has to do everything from scratch. Okay. This might take a very long time. Now, to cut short the time, what you do is, since it will take a lot of time to find actually out, you do go for a gray box testing, somewhere between white and black box. You give certain amount of information which will take time for you to search. Say, in the sea of IP, if I have to try to find out your a particular IP through which I want to get in, it is a difficult task. I may not be able to come to know. So I give you the penetration inroads, that IP address through which you can actually penetrate. Okay, so you do not have to locate and try to do a lot of assessments to find out what is the exact IP from where this organization is communicating. What is the internet gateway of an organization? That's the most difficult part for a penetration tester to find out. It's not that difficult, but it will take some time, right? So that's why you go for a gray box approach generally during penetration testing through external agencies. Okay. Then next part in security testing is compliance checks. Okay. So you might be under certain compliance and you carry out internal compliance checks, wherein you go through compliance, checklists and see that you meet all the checkpoints and you follow those checkpoints. Okay. You can evaluate the controls and see that as far as compliance is concerned, you are meeting all the points.